Imagine waking up one day to find time has stopped. What would that mean for you in the universe? Everything around you frozen, no movement, no change. This is the mind-bending concept of time stopping, a topic that has fascinated scientists and philosophers for centuries. What is time really? Is it a fundamental property of the universe or simply a human construct? These questions have puzzled some of the greatest minds. Join me as we delve into the mysteries of time, explore the possibility of its end, and contemplate the implications for the cosmos. In our everyday lives, we experience time as a linear progression from the past, through the present, to the future. We measure it with clocks and calendars, marking the passage of days, years, and centuries. But what is time exactly from a scientific perspective? Physicists describe time as a dimension, much like space. Just as we can move through space in 3 dimensions, up, down, left, right, forward, backward, we also move through time. However, unlike space, we can only move through time in one direction, forward. This unidirectional flow of time is what gives us the perception of past, present, and future. It is also intimately connected to the concept of causality, the idea that events in the past cause events in the future. While the idea of time stopping might seem like science fiction, some scientific theories suggest that it could actually happen. One such theory is the Big Crunch, a hypothetical scenario in which the expansion of the universe reverses and everything collapses back in on itself. If the Big Crunch were to occur, the density and temperature of the universe would increase infinitely, leading to a singularity, a point of infinite density and zero volume. At this point, time as we know it would cease to exist. Another theory that predicts the end of time is related to the concept of entropy. Entropy is a measure of disorder or randomness in a system. The second law of thermodynamics states that entropy in the universe always increases over time. If you want a glimpse of the mind-boggling effects of time distortion, look no further than black holes. These enigmatic entities are not just fascinating, they are the ultimate time-bending behemoths of the cosmos. These cosmic monsters possess gravitational pulls so intense that nothing, not even light, can escape their grasp. The sheer force they exert on their surroundings is enough to warp the very fabric of space-time itself. What happens to time near a black hole? It gets weirder. Time, as we understand it, begins to behave in ways that defy our everyday experiences and expectations. Imagine you could observe a spaceship venturing closer and closer to a black hole. From a safe distance, you would witness phenomena that seem straight out of science fiction. From your distant vantage point, you'd see the ship appear to slow down, its light becoming increasingly redshifted as it struggles to escape the black hole's gravitational clutches. This redshift is a direct consequence of the intense gravitational field affecting the light's wavelength. As it approaches the event horizon, the point of no return, the ship would seem to freeze in time, its image forever stuck on the precipice of oblivion. This is because the gravitational pull is so strong that time itself appears to come to a standstill. But for someone on board the spaceship, time would continue to flow normally, at least initially. They would be unaware of the bizarre time dilation effects happening outside their vessel. They wouldn't feel any slowing down or strange effects. To them, everything would seem as it always has, with clocks ticking and life proceeding as usual. However, as they plunge deeper into the black hole's gravitational well, the immense tidal forces would eventually rip them apart, a process aptly named spaghettification. This gruesome end is due to the extreme difference in gravitational pull between different parts of their body, stretching them into long, thin shapes. Black holes remain one of the most mysterious and awe-inspiring phenomena in the universe. They challenge our understanding of physics and push the boundaries of what we know about time and space. As we continue to study these cosmic giants, we may one day unlock the secrets they hold, revealing even more about the nature of our universe. A universe frozen in time. Now let's imagine for a moment that time were to stop completely throughout the entire universe. What would it be like? At first glance it might seem peaceful. A universe frozen in a state of perpetual stillness. But upon closer examination, the implications are far more profound and even a bit eerie. For starters, if time stopped, all motion would cease. Atoms would no longer vibrate, light would no longer travel, and planets would halt their orbits. The universe would become a cosmic still life, a snapshot of a single moment in time, stretched out for eternity. In this timeless state, there would be no past, no present, and no future. Everything that ever was, is, and ever will be would exist simultaneously, yet be utterly inaccessible. The concept of causality would break down completely, as there would be no flow of time for events to follow one another. The paradox of stopped time. The very notion of time stopping presents us with a paradox. If time were to stop, how could we possibly know it? After all, our perception of time is what allows us to observe change and measure the passage of moments. Without time, there would be no before and after to compare. This paradox highlights the intricate relationship between time and consciousness. Our experience of time is fundamentally intertwined with our awareness and our ability to perceive change. If time were to stop, our consciousness, as we know it, would likely cease to exist as well. So, while the idea of time stopping might make for an intriguing thought experiment, it is ultimately a concept that lies beyond the realm of human comprehension. The quantum realm, where time gets fuzzy. When we delve into the bizarre world of quantum mechanics, the rules of classical physics, including our intuitive understanding of time, start to break down. The familiar, predictable flow of time that we experience in our everyday lives becomes something far more complex and elusive. In the quantum realm, time becomes less of a straight line and more of a blurry, uncertain mess. It's as if time itself is a fluid, constantly shifting and changing, defying our attempts to pin it down. One of the most mind-boggling aspects of quantum mechanics is the idea of superposition, where particles can exist in multiple states or locations simultaneously until observed. This phenomenon challenges our very perception of reality. In superposition, a particle doesn't just have one definite state, it has a range of possible states. It's only when we measure or observe the particle that it chooses a specific state. This idea is not just theoretical, it has been demonstrated in numerous experiments. This challenges our classical notion of time as a rigid framework for events. In the quantum world, time is more like a canvas that can be stretched, twisted, and reshaped in ways that defy our everyday experiences. If a particle doesn't have a definite state until observed, does it really exist in time as we understand it? This question strikes at the heart of our understanding of existence and reality. Furthermore, quantum entanglement throws another wrench into our understanding of time. Entangled particles share a connection that transcends space and time, linking their states instantaneously. Two entangled particles, no matter how far apart, can instantaneously influence each other's states. This phenomenon suggests that information can travel faster than the speed of light, defying the conventional limits of space-time. This spooky action at a distance, as Einstein famously called it, seems to defy the limitations of time and space. It raises profound questions about the nature of reality and the true fabric of the universe. How can information travel between 2 points without any time passing? This question remains one of the greatest mysteries in quantum mechanics, challenging our understanding of the universe and the very nature of time itself. Beyond the end of time. If time were to end, what would lie beyond? This is a question that has fascinated humanity for centuries, a question that pushes the boundaries of our understanding and imagination. This question takes us firmly into the realm of speculation, where even the most daring physicists tread lightly. It challenges the very fabric of our scientific knowledge and philosophical beliefs. Some theories propose that our universe is just one of many, in a vast multiverse, a collection of countless universes, each with its own unique properties. Each of these universes could have its own unique set of laws of physics, and perhaps even its own experience of time. Imagine a universe where the speed of light is different, or where gravity works in reverse. Perhaps in some universes time flows backward or not at all. The very concept of time could be as varied as the stars in the sky. Perhaps there are dimensions beyond our comprehension, realms where the rules we take for granted simply do not apply. In these higher dimensions, time might be just one of countless dimensions, interwoven into a tapestry of reality so complex that our minds can scarcely begin to grasp it. This intricate web of existence could be far more elaborate than anything we can currently conceive, a network of realities interconnected in ways we cannot yet understand. Or maybe, just maybe, the end of time in our universe wouldn't be the end of everything. It could be a transition, a gateway to another form of existence. Perhaps it would be the beginning of something new, a rebirth of sorts, where the end of one reality gives rise to another. This transformation could lead to a state of being so fundamentally different from our current existence that we lack the words or concepts to describe it. It would be a metamorphosis on a cosmic scale. In this new state, the very essence of reality could be redefined, giving birth to new elements, new forms of life, and new ways of understanding the universe. Beyond the end of time, the possibilities are as infinite as the cosmos itself. Time travel and the illusion of time. The concept of time travel has captivated the human imagination for centuries. But is it truly possible to journey through time? Or is it merely a product of our desire to rewrite the past or glimpse the future? Einstein's theory of relativity suggests that time travel might be possible, at least in a theoretical sense. According to relativity, time is relative to the observer's frame of reference. This means that time can pass at different rates for observers who are moving at different speeds or experiencing different gravitational fields. While the idea of traveling through time is tantalizing, it also raises a host of paradoxes and logical inconsistencies. For example, if time travel were possible, one could conceivably go back in time and prevent their own birth, creating a paradox that throws the very fabric of causality into disarray. The human experience of a timeless universe. In a universe devoid of time, our human experience would be fundamentally altered. Our memories, our hopes, our regrets, all are intricately woven into the fabric of time. Without the passage of time, what would become of our sense of self, our relationships, our very understanding of existence? Would we even be capable of experiencing such a universe? Our brains, our thoughts, our emotions, all are products of biochemical processes that occur over time. Without time, would these processes simply cease, leaving us as empty vessels devoid of consciousness? Or perhaps in a timeless universe we would transcend our current limitations and achieve a higher state of being, one in which the boundaries of self and other dissolve and we merge with the infinite. It is a question that sparks the imagination and leads us down endless paths of philosophical inquiry. The unknowable nature of time. The concept of time, both its beginning and its potential end, remains one of the most profound mysteries of the universe. While our scientific understanding of time has advanced significantly over the centuries, we are still far from unraveling all its secrets. Perhaps time is not something to be conquered or understood, but rather something to be experienced and cherished. It is the canvas upon which we paint our lives, the rhythm to which we dance, the river that carries us from the cradle to the grave. So, the next time you find yourself lost in the hustle and bustle of life, take a moment to ponder the enigmatic nature of time. Reflect on the moments that make up your life, the memories you hold dear, and the dreams you strive to achieve. For time, in all its mystery and wonder, is the most precious gift we possess.